Welcome to the lecture on microcontroller programming. In today's lecture, we are going to look at and understand languages that are required to program the microcontroller in general. So, as we have said, microcontroller is a programming device which can be programmed to perform a specific task. So, to perform a task, it has to perform a number of operations in sequence. And to perform each operation, we have to give instruction for the controller. And then how we can give instruction to the microcontroller? So the instruction can be given in which language? So as you know, the microcontroller is basically a digital circuit, and a digital circuit, any digital circuit understands only the language of ones and zeros. So we say that it has a binary language. So in order to give instructions to the controller, then in which language we have to write, or in which language we have to give instructions, or what are the various types of languages that are there, that will be discussed in today's class. So this is the overview of the second unit, which discusses about the languages in which we write our instructions or programs for 8051 microcontroller. And the second part discuss about the addressing modes of 8051. We'll see what are these in detail later. So before going to write, or before going to understand what are the various programming languages in which we can write programs for 8051, we'll see basic terminology like what is in my programming language, or what is a programming language. So programming means what is in my programming. So programming means, if in the sense of microcontrollers, means we'll write instructions, certain number of instructions, and certain number of instructions in sequence. And when microcontroller reads each instruction and executes each instruction, it performs a particular task. And after executing all these instructions that we have written for microcontroller in sequence, then it is going to perform the predefined task for which we have written program for 8051. So here it goes that programming is, in the sense of microcontrollers or any computer, means writing sequence of instructions. So this writing sequence of instructions, we call it as a program, and these sequence of instructions are executed in the same sequence or as indicated by the instruction by the processor that is present inside your 8051. And finally, after executing all these instructions, it will perform the required task that the microcontroller is intended to perform. So programming not only involves writing the sequence of instructions, but it also involves debugging and troubleshooting. So what are these? So what is meant by debugging? So debugging means so when we are writing program, that means when we are writing the sequence of instructions, there maybe some of mistakes that may occur uh, that are not recognized by your controller when it reads, and that is called as bug. So a bug means a mistake or error, and removing and identifying the errors from the program is called as debugging. And we have one more task in the programming, that is called troubleshooting. So even though we write program or sequence of instructions for the 8051, the controller may not perform the desired task, or it may have some deviation, or the output may have some deviation from the desired task. So in order to find out where the sequence of instructions or program has gone wrong, we have to find out the problem. So that is problem, and we have to rectify it. That is called troubleshooting. So overall, we can say that the programming in the sense of microcontroller means three things. One is writing sequence of instructions and debugging the errors and troubleshooting the program. So then in which language we can write this sequence of instructions? Can we write in so if you see the humans have number of languages to communicate. But can we use the same languages to give instructions for the 8051? We can't, because 8051 is a circuit, a digital circuit, which can only understand ones and zeros. So there are different programming languages which we can use to give instructions for the 8051, or which we can use to write instructions for 8051, and they are said to be as there are three levels of programming languages, and these levels refers to uh, the levels are the comfort levels of either machine or human. So these three levels, you can say that one is machine language, another is assembly language, another is a high level language. So that means we can write instructions for 8051 by using any of these three levels of programming languages. One is either you can write in machine language, or you can write in assembly language, or also you can write in high level language. So let's see what is meant by machine language and assembly language and high level language, and how the instructions written by using these languages look like. And we'll see a sample instructions, and we'll see the differences or the advantages and disadvantages of writing instructions in one of these languages when compared to the other. So first we'll go with the machine language. So what is meant by machine language? The language which can be easily understood by machine. Or I can say that machine here it means the 8051 controller. So a program is written in the form of zeros and ones. It's called machine language, because the only language understood by your digital circuits is ones and zeros, because they know just whether the switch is on or off. That means they know just uh, the alphabets zeros and ones. So if you want to give instructions, or if you want to write instructions for 8051, you have to write in the language that the machine knows, that is in ones and zeros. Then how an instruction written in machine language looks like. So we have an example here. So if we want to add the two numbers, the two 8-bit numbers say, so we have already discussed there are certain registers and register names and so on. Everything is discussed in the architecture while we discussed the architecture of 8051. So when we want to add two 8-bit numbers, one for example is stored in register A, and say for example the other number is stored in register R7, and if you want to give instruction for the 8051 to add these two numbers, so that means the machine code for adding the contents of register A and R7 is, so machine code means now we are writing the instruction by using machine language, and the instruction that we give in machine language is sometimes called as machine code, and the machine code that we have to write for adding the contents means one of the number is stored in register A and another number is stored in R7 is, the machine code looks like 00101111. So you can see that when we give 00101111 as an instruction for 8051, it understands that there are two numbers, one is in register A and one is in R7, and it has to add the contents of the both the registers. So this is what the controller understands by looking at these 8 bits. And similarly, we look at one more example how the machine code will differ when we write one more different instruction. So here we have a certain 8-bit number in R7 register, and we want to move that number 1 byte data. I say 8-bit data means it's a 1 byte data. So 1 byte data that is present in R7 register, I want that to move into register A. And who has to move this? Actually, this is to be moved by your controller. But we have to give instruction for the controller, and if we write the instruction in machine language, the machine code will be 11101111. So that means if we give these 8 bits for the microcontroller 8051, it understands that there is a 1 byte of data in R7 and it has to be moved to register A when it executes this machine code. Okay? So this is how we'll write the instructions in machine language, or this is how we'll write machine codes to perform certain number of operations. So each of these machine code will perform an operation, and if you want to perform a big task, you have to write these machine codes in sequence, and when all these machine codes are executed, the controller will perform the task. So then what is the advantage of the machine language? So you can see that the machine understands ones and zeros only, and now we are writing the instructions for 8051 in one sign by using ones and zeros only. So it is the most well known language by machine, so that it can be directly executed by the CPU of the microcontroller. So this is one big advantage when we write instructions for 8051 using machine language. because it is the language of machine, so it can directly execute, and the execution is also very fast. That means it will take less time. But you can see that you observe the machine codes. For addition of to perform this operation, you have to remember this machine code, and to perform this operation, you have to remember this machine code. So for the programmer, it will be very difficult to remember the machine codes, and if at all there is a bug, that means here, if at all, if this 1 changes to 0, it is very difficult for the programmer to find out where is the bug, and to rectify it, it is very difficult. So next we'll look at and one more thing that we need to discuss about machine language is when we write instructions in machine language, it is machine dependent. That means if we write instruction to add two numbers, say for example one is present in register A and another is present in R7, we cannot ask the other machine to execute the same instruction. That means we have written this instruction by keeping the architecture of 8051 in view, and if we supply the same instruction to some other microcontroller, it may or may not execute. So that is why we say that the instructions written in machine language or machine code are machine dependent. That means you can only execute the machine codes written for 8051 on 8051 only. You cannot execute those instructions in other microcontrollers, or other microcontrollers cannot execute the machine codes written for 8051. So this is also a big disadvantage. That means when we want to change the microcontroller, we have to change our instruction or machine code. Now we look at the one more level of language, that is called assembly language. So what is meant by assembly language? So it's a program written in mnemonics. It's a program written in mnemonics compared to your binary machine language where the program was written using ones and zeros. So now here the program is written using mnemonics. So then what is meant by mnemonic? You can see that the mnemonic is a group of alphabets which suggest operation to be performed by that instruction. That means, for example, what are the various? So it's a small word. It's a small or it's a group of alphabets. It suggests what is the operation performed by that instruction when it is executed. So not exactly these are the English words, but they are the certain shortcuts or abbreviation like words using English alphabets only, but they will suggest the operation. For example, if you want to, we have an example. So here you can see that we are using a mnemonic that is formed by a group of alphabets A, B, D in caps, and this is the mnemonic written to perform the operation of addition of two data bytes. So if you want to add two data bytes, we'll use simply the mnemonic ADD. And where are the data bytes? So that is different, but just this mnemonic just indicates the operation called addition. Right? Similarly, we have one more example. where we have the mnemonic div, and this mnemonic suggests an operation of division of the two numbers. So, what are the advantages and what are the features of this assembly language when compared to your machine language? So, you can see that um, so the instructions written using assembly language are very easy to read. As you can see, if we write the instruction using assembly language, that is by using mnemonics, we simply have to write ADD, and this instruction um, written using mnemonics is very easy to read and to write and to debug also. So you can see if there is some mistake in this mnemonic, if in place of ADD if we have ADE, then it is very easy to find the bug and to debug the instruction. So instead of as we have seen in machine language, where we have used ones and zeros to write the instructions, and where we have felt that writing instructions and remembering the instruction and debugging instruction is very difficult. Compared to that, um, reading and writing and debugging the instruction in assembly language is very easy, as the instructions are written using mnemonics. And since these mnemonics suggest the operation that is to be performed by that instruction, we can very easily remember all these mnemonics also. And like the machine language, the assembly language instructions, so ALP here stands for assembly language program. So assembly language program is a sequence of instructions written using assembly language are also machine dependent. That means the program written for one microcontroller will not be executed by a different microcontroller. That means the program is specific to the particular machine for which we have written the instructions. So that means if we write a assembly language program for 8051, the program will be executed only by 8051 but not by others. So then that is called as machine dependent, and our assembly language program is also machine dependent. That is, it is also not portable. That means we cannot um, uh, give this program to another microcontroller. But there is a problem when it comes to the execution part, that is read and perform. So what is in the execution here? To read, understand and perform the required operation. So as you know that since we have written the instructions by using mnemonics, which are a group of alphabets, do you think that these group of alphabets are understood by 8051 directly? No, because 8051 is a digital circuit which can only understand or which can only know the ones and zeros. It doesn't know what is in by A, what is in by D, and what is in by this mnemonic ADD. So when we give the instructions written using mnemonics, the microcontroller cannot understand directly and it cannot execute the assembly language program directly. So then how uh, the controller can execute the assembly language program? So here if you can see, there is a small picture that is shown here, and the first page actually indicates the program written using mnemonics. That means this program is written using assembly language, but you know that this is not directly understood or executed by the microcontroller. And you can see there is one more page where we have written the program by using ones and zeros, that is by using machine code. And you know that this machine code easily understood or directly executed by the 8051. So due to some of the difficulties that we discussed in the previous slide, we are avoiding writing instructions in machine code. We are avoiding writing machine code because it was difficult to write and debug. We actually wanted to go for some simple method of writing programs, and that by using our assembly language. But assembly language is not understood by machine, and machine code is difficult to write for humans. Then what is the solution? So the solution is a small software called assembler, which which will give the assembly language program as for which we will supply the assembly language program written using mnemonics. And this assembler is the software which converts this assembly language program into machine language program. So the solution is here assembler software. Okay, so though we write the instructions using assembly language, that is by using mnemonics, we will be using a software called assembler to convert the program to machine code, and this machine code now it can be directly executed by your controller. So that is what we have given here, not directly executed by machine code but requires a software program called assembler to convert the assembly language program into machine code first. So just so this is what about the assembly language and how the instruction look in assembly language written look when we write using assembly language, and what are the difficulties faced, what is required to overcome that. And next we will compare our machine language with the assembly language. So what are the various aspects of, what are the differences between the two languages. So if you go with the machine languages first, the operations specified by binary codes, that is by ones and zeros, that every operation, whether it is addition or moving or copying or something else, it is specified by using ones and zeros, that is they are called binary codes. And coming to assembly language, how the operations are specified, they are by using mnemonics. And the second point of difference is the programs written in machine language can be executed directly by CPU as the ones and zeros. The machine language means it is using ones and zeros, and the ones and zeros are the easily understood by CPU, so it can directly execute. And coming to assembly language, programs written in assembly language cannot be executed directly by CPU because the programs written by using mnemonics here, and mnemonics are not directly understood by CPU or cannot understood by CPU. And here machine language, coming to machine language side, it doesn't require any assembler because programs are written in machine code which is easily understood by CPU or controller directly, and no need of any extra software called assembler. But coming to assembly language, an assembler is required here to convert an assembly language program to machine language first before it is being executed by controller, because here the instructions are written by using mnemonics which are not directly understood by controller. First the mnemonics should be converted to machine language first. And coming to the debugging, ease of debugging, when you see the machine language, since the instructions are written using binary codes, it is very difficult to write and debug programs in machine language. And also since the mm, instructions are written using ones and zeros, they are directly executed or fastly executed by the controller. And similarly, coming to assembly language, with respect to the ease of debug, comparatively it is very easy to write and debug the programs, as here we are writing the instructions by using mnemonics, which are easy to remember and to find uh, bugs. And here you can see that the execution of the instructions written in assembly language are slower because they must be first converted to machine language by using certain other software called assembler, which takes a bit longer time compared to the execution of instructions written in machine language. So here, in the overall point of view, the machine language is the 8051 controller has comfort when you write instructions using machine language, but it is difficult for the programmer to handle. But when you are using assembly language to write program, um, it is very easy for the programmer to write the programs and debug the programs, but the controller requires a software called assembler to convert the assembly language program to machine language first. So next we'll see the comparison between low level language and high level language. So we'll not be using the high level language in our curriculum. So but as we said that there are three levels of language: machine language and assembly level language and high level language. So machine and assembly language will come under low level language, and high level language is something in high level language we write instructions by using some English like words. So the example for high level language is C programming language. So just as per curriculum we will just compare the points, various aspects uh, with respect to the high level language and low level language. Here you can see that the high level language, it's a very programmer friendly language, and you can see that as it is written in using English uh, like words, English words, it is very friendly language for the programmer because it matches with his language, usage language. And here one more thing you can see that about high level language requires more program memory for program for given program. So more memory for given programs. That means when you write the instruction using high level language, it takes a lot of memory for the same program when compared to the programs written in low level language. And but high level language has certain advantages that it is very easy to read and debug. That means since it is in the same language of user, it is very easy to read and debug. And you can also see that the programming languages written in high level by using high level language are portable. That means program written for one machine can also be executed by a different machine. So that means, so if you write a program to perform a certain task, then the same program can be executed by any different machine. So that means no need to write different programs for different machines. So that is, I can say that high level language is portable. And but you can see that the high level language, which where instructions are written using English words, and you can see that these English words cannot be understood by the machine. So there must be a translator software which converts the high level language to the machine language, and that translating software is called as compiler. Okay, so here I can say that the high level language needs a compiler for translation to machine language. and you can see that the high level language is easy and quick to write programs as they require less number of statements, right? So we can write the programs by using high level language in a very quick, less time, and it is very easy because the language uses the simple English words to write instructions. And when coming to the low level language, we can see that what we have discussed in machine language and assembly language are low level languages only. And here you can see the low level language is machine friendly language. That is, it is more, the machine feels more comfortable with that language because it is written in the same language as understood by the machine. And low level language has, it is written using ones and zeros, requires a less memory for a given program, and since it is written using binary codes, very complex to debug and read, and it is not portable also, that is, it is machine dependent. It means programs written for one machine will not be executed by the other machine, and it needs an assembler for translation in case of assembly language program. Writing program takes a relatively large number of instructions. So since it is written using ones and zeros and or by using mnemonics, a large number of instructions are required to write the same program when compared to high level language. Okay, so this is all about the three programming languages and what are the differences or comparisons between the three levels of language. So here for this high level language and low level language, you know, if you want to give overall view, the writing programs in high level language is programmer friendly, and a program written for one machine is also executed by another machine also, and it takes less number of statements. And compared to coming to low level language, writing programs using low level language takes a lot of instructions, and it is very complex to debug, and it is also not portable. That means programs written for one machine are not executed by the other machine. Okay, so next we'll go for one more topic called what is the need for assembly language. So we have three languages in total: machine language, high level language, and assembly language. So then which language is preferred to write instructions for 8051 and why? So we prefer the assembly language to write to give instructions, to write instructions for 8051. Then what is the advantage that is making us to write the programs in assembly language? So you can see that one thing, the assembly language provides a direct and accurate control of microcontroller resources. That means we have seen in the previous lecture when we studying about the architecture of microcontroller, we have seen that what are the various features that it has, how much memory it has, how many ports it has, or what is the various hardware that is present inside. And our assembly language, when we write the instruction using assembly language, the instruction uses the perfect usage of the circuits inside your 8051. So that is called efficient use, efficient and accurate control of the controller resources is achieved when you write instructions by using assembly language. And also assembly language program requires less memory compared to a high level language, and the programs will be executed fast. So if the programs are executed fast, then the controller will require less amount of time to perform the same task. So that's why we'll be preferring the assembly language program. And this ends the lecture on the various languages and their comparison of various features of the languages in which we can write instructions for 805. Thank you.